Related rates, part 3. In this video, I'm going to do just one problem. And it's a very typical problem that I use to help students work through the process of related rates. So we have a cone, point down, that has a height of 10 inches and a radius of 2 inches. That's the cone itself. And it's being filled with water at a constant rate of 2 inches cubed per second. How fast is the water rising when the water depth is 6 inches? Let's start, as always, by drawing a picture. So I have a cone. And I know its height is 10 inches. Well, water's coming up here, so let's draw some water here as well. Now, the water height is changing, but the cone height is not. So we will call the cone 10. And then the radius of this cone is also not changing, so we'll call that 2 because it's fixed. And we'll draw something like this. Let's continue. Let's see if there's anything I can label. Well, let's take this piece of information here first, because I'm not really sure how to label this picture. It's one of the reasons I like this problem, because students often, they're not really sure how to label this either. But if I look, it says the water is filling at a rate of 2 inches cubed per second. So something is changing. Now, what's changing? The units tell me that is volume. So I have a change in volume, because we have inches cubed, per time per second. Okay, so I'm probably going to need a volume equation. We'll get to that in just a bit. And it says, how fast is the water rising? Okay, so I have water, and I have a water depth. Let's call that H. So I'm trying to find dH dt when H equals 6. Is there anything else I should label in this equation? Well, I'm still not sure yet. But I do know that since I need to take a derivative of the variables that are related, I need that equation. And I know that the volume of a cone is pi over 3 r squared h. And just looking at my equation that has an r in it, it says, you know what, I probably should label that r as well. So I'm going to go back and look. Is there any other information given or implied that helps me draw the picture or come up with anything else? And at this point, I don't see anything else, so I'm going to take the derivative of my equation with respect to time. So I get dv dt on the left side. Great. I'm going to pull out my constant. I like to leave the constant alone. And then I'm going to do a product rule on r squared h. So we have 2r. Variables don't match, so we chain out. Leave the h alone. Plus is very common that students don't do the product rule where they should, because it's a product. Now plus, leave the r squared alone, times the derivative of the h and chain out. And I get times dH dt. The only thing I shouldn't know is it's dH dt. I have dV dt. I know h, trying to find dH dt. But I think you see the problem already. I should know r and dr dt. And I don't. Does that mean I did something wrong? Perhaps. Usually, though, it means I missed something. So what did I miss? Let me go back and erase all this. I want a little bit of space here, because I know what I missed, and I want some space for it. So what did I miss? Well, I missed something in my picture. Notice that in my picture over here, if I emphasize it a little bit more, I've never used the 10 or the 2. And if I give you something, you probably need to use it. And I see in my picture with the emphasis that I have similar triangles. That is, R over H equals 2 over 10, always in the context of the problem. Which means R is always 1/5 of H. Now I could have used this and plugged into the equation or the derivative equation that I just erased, but instead I'm going to plug this into my volume equation. So if the volume is pi over 3 r squared h, then I know that volume is pi over 3 times r squared, watch this, 1/5 h squared times h. Because r is 1/5 h always in this problem. So if I simplify this, I get pi, and then I get h cubed, and then I get 3 times 25 in the denominator. And I actually have a much simpler equation for volume. We can take the derivative of this one with respect to time, giving us dv dt equals 3 pi over 75 h squared times dh dt. Now, if I plug in what I know, dv dt equals 2, h is 6, and the only thing that I don't know is what I'm trying to find. That is, I can now solve for dh dt, how fast the water is rising. So I get dh dt is 50 over 36 pi. H is one-dimensional, so inches per second.